Hello everyone, welcome to the next lecture. Today we will discuss about the PY questions on the linear algebra. We will cover all those questions from the year 2011 to 2023. This is the part 1. We will cover the second video after this one. Myself Dr. Harish Garg. You can simply follow my YouTube channel Dr. Harish Garg, else simply scan and join my WhatsApp group for more update videos. What you will be found on my YouTube channel, there is a playlist of the CSR UGC net where you can find the PY questions on the partial differential equation, real analysis, ordinary differential equation, Markov chain, and many more in this here. You can see all the PY questions from the last 12 years in this playlist of here. You can see the shortcut tricks in as well. So let's start with this video. We will cover the 70 plus question in this part and the next 70 plus question related to the December 11 to 23 in which we will upload it after this video. So let's start with this one. So remember, whenever you are solving the linear algebra question, read the statement very carefully. What is given to you? A is a 5 cross 5 matrix such that Aij is either 0 or 1. Then such that the sum of the each row is 1, sum of the each column is 1. So what kind of the matrix is there? And Aij is either 0 or 1. For example, if I put up as a 0, either you can put up as a 1 here, or you may put 1 in the second column, or you may put 1 as a third column, such that the row sum will be 1. So what is that? How many choices you have in the first case? That is a 5. So in the second case, when you fit as here, then definitely this value will be 0 because you have the column 1 and the row 1 as 1. So how many choices you have? 4. Like of this, I can put this as a 1. Once you put this column as a 1, then how many choices you left? 3, then 2, and the last one there is no choice, there is a 1. So what is the meaning of that? It's a 5 factorial. So the right answer is my 5 factorial is the correct answer. Otherwise, whenever there is a matrix of the form 0 or 1 such that the row sum and the column sum is 1, we will call this as a permutation matrix. And the right answer of this problem is n factorial. That's a simple tips for you. What is the n is? 5 cross 5, so the right answer is 5 factorial. Look at the second example. Here m is given to you. There are the three vectors a1 and a2, a3 such that these values are lies between 1, 2, 3 and 4 such that the sum of them will be 6. Here it is not a matrix. Remember, it is not a square matrix. If it is a square matrix, then you can write as a permutation. But what are those options? You can see the sum of them will be 6. Can you find the number of the linear independent? Or you can say the rank of this line is, if I call this as a matrix A, rank of this matrix is 1. What is the nullity of this matrix? You can see 3 minus 1, 2. So you have the 2 independent vectors. Now, if I can choose, what is the choices of the A1? A1, you can choose either the 4, you can choose either 3, you can choose either 2, and you can choose either 1. So there are 4 choices for the A1. Now what are the choices for the A2? If you take A1 as a 4, it means this sum will be my 2. And since none of the number is my 0, so what are those values? Both is my 1, 1. So that means there is a 1 choice for them. When you take A1 is 3, the sum of them will be 3. So what are the choices? Either you can take A2, this is a choice for the A1. What is the choice of A2? Either you can take 1 or you can take 2. If I take A1 is my 2, then what is the choices of the A2 plus A3? It must be my 4. So what are the choices for that? Either you can take A2 as a 1, either you can do as 2, or either, but you can never take as a 3. Because if you take as a 3, what will happen? It is possible also. If it is 3, then other value will be 1 as well. If you take A1 is my 1, what are the choices for the A? What is the A2 plus A3? It will be 5. So what is that? It could be 4, it could be 3, it could be 2. So how many choices you have? Or it could be like of 1. So how many choices you have? 4, 3, 2, 1. So 4, 3 plus 2 plus 1. So 4 plus 3 plus 2 is the right answer of this problem. Look at that dimension of the matrix. Now here is given to you n cross n. So what is the shortcut tips for you? You always choose the value of the n as per your convenience. Here the simplest way is you can choose 2 cross 2. Fine. Now once it's a 2 cross 2, you have to find the dimension. Real entries, trace is my 0. So if I call this is my a, there is no need to find this value because you know this value will be minus a. And you know this is a symmetric matrix. If this is my b, then this number is automatically you can compute as a b. So how many unknown vectors in this 2 cross 2? That is my 2. So that means you can check what will happen if n is equal to 2. So it is 4 minus 2 over 2, which is not equal to 2 because so this option is cancelled. 4 plus 2 over 2 minus 1 is a 2. So there's a correct answer. 4 minus 4 over 2 minus 1 is minus 1, which is not equal to 2. Cancel out. 4 plus 4 divided by 2 is 3, which is not equal to 2. So right answer is only by B is the correct answer. Simply you can choose any of the pair. You can choose 3 cross 3 as well, but the simplest way is 2 cross 2. Okay, look at that. A and B are my n cross n matrix. So again you can simply choose as my 2 cross 2. So if I take A is my I, because nothing is given to you. So what is the meaning of that? This will be my trace of B square. So look at that. The first answer option will be trace of AB. If A is my I, then AB will be I. So it is a whole square. That's a wrong statement. Why? Because we know if B has the eigenvalue this, then the B square has the eigenvalue this. Then what is the trace of the B square? It is this one. But trace of this is here. So it is not equal to this pair. So the first option is cancelled. When A is equal to I, this is the trace of B square, that's the same, but we can never say it's a correct answer. Whenever you provide the example, counter example, your target is to discard them. This is trace of B square, again same. This is trace of B square, again same. So it means nothing is to be discarded. Now, what is that? If I consider A is equal to B, both are same. So this is my trace of A raised to power 4. This is again A raised to power 4. This is again A raised to power 4. This is again A raised to power 4. So again this example does not give you. Then what is the tips for you? So we all know trace of the ABC, which is nothing but my, you can change them to be here, CAB. Remember, this is applicable only for the 3 case. Remember, this is not true. You can't say for the 2. You can't say you can change them to be here. This is not true. This is only applicable for 3 or more than 3. So now what will happen if I write A square as a AA, B square as a BB? Fine. Now I can change them to be here. So it is a BAAB. Is there any pair? No. Again I can change BBAA. Is it anyone? No. This is ABBA, not match. Again we can change ABBA. Is this match? ABBA. So this is the right answer of this problem. If you want to again change, then it's again the same. So this is the right answer. B is the correct answer. Rest all options are cancelled. Okay, now look at this next question. A is the any 2 cross 2 matrix such that this will be here. That's very simple. What are the, whenever there is a matrix, you can think about the eigenvalue. What are the eigenvalue of this? I can simply take lambda 1, lambda 2. What is the eigenvalue of the A plus I? This is my eigenvalue of the A plus I. Now you can substitute here. What is the determinant of this? That is a product of the eigenvalue, which is 1 plus of here. Now if you open them, this will be cancelled out. 1 will be cancelled out. The only pair will be here. What is the meaning of that? This is trace of A is my 0 is the correct answer of the problem. Okay, now look at this one. Again it's a n cross n and n is my 2. So I can simply take is my 2 cross 2 matrix. Fine. Now think about the first option. Determinant is my 0. So what you can think about that? This is my 2 cross 2. clearly says that the determinant of this matrix is 0, satisfied. What is the rank? Rank of this matrix is my 1, which is non-zero. First option cancel out. Again you can see the rank is my 1. This again example satisfied. What is the determinant? The determinant of this is my 0, but he said non-zero. This option also cancel out. Then think about the determinant is my 1. So this is the example where you can see the determinant is 1. What is the rank of this matrix? Rank is my 2, but it said not equal to 1. That's also correct, not equal to 1. So we can't see anything. Look at that. I have taken n is my 2, rank is my 2. So again you can see rank is my 2, determinant is not equal to 1, but you can see what is the determinant of this matrix, which is 1. So this option is cancel out. Right answer is my B. Whenever there is a n cross n, you can take the example for your own convenience. Again you can see this is a 2022. A sequence of the Fibonacci series is defined like of this one: an minus 1, an minus 2 for all n greater than 2. So can I write this one? an minus 1, an minus 2 is 0. So how many variables are there? Number of the variables are my 3. What is the rank of this matrix? Clearly says it's a 1. So the number of free variable, or you can say the nullity. What is the nullity of this is 3 minus 1 is my 2. And your target is to find, because this is the right hand side is 0. So what is the meaning of that? I can return this as dimension of the ax is equal to 0. That is nothing but my nullity. So what is the nullity is my 2 is the right answer of the problem. Okay, what is the trace of the a plus b? We all know trace of a plus b is trace of a, trace of b. A are the eigenvalues. So what are the trace of this? Sum of them, it is minus 1. What is the trace of b? We need to find that. When a has the eigenvalue minus 1, so what are the eigenvalue of the b? 1 minus 5 plus 5, that is a 1. When it has a 1 eigenvalue, so b again has the 1 minus 5 plus 5, 1. When it is again 1, so again it has a 1. When it has a minus 2, then b will be 16. It's a 4, 20, it's a 5. So it's a 21, it's a 1. So what is the trace of this? What is the trace of the b? These are the eigens value of the b. So trace is my 4. If you substitute them, answer is my 3 is the correct answer. Now again it's n cross n, so I can simply take a 2 cross 2 matrix. Fine. So it has a 4 elements. So A110, so this is my 0. Trace is also 0, so definitely this number will be my 0. So there is no need to them. It is a symmetric matrix. So if I consider this is my A, then there is no need to find this. It is automatically be minus A. So how many independent variables are there? There is only one variable called as this element. So now I take n is 2. I can substitute here, check whichever answer is 1. So it is 4 plus 2 minus 4 over 2 is a 1, correct answer. Because there is only one correct option, that is over. But we can check others also. 4 minus 2 plus 4, which is not equal to 1. 4 plus 2 minus 3 over 2 is not equal to 1. 4 minus 2 plus 3 is again not equal to 1. So the right answer is only my A is the correct answer. Okay, which of the following is the eigenvalue? So we all know what is the properties of the eigenvalue. Trace of the A is sum of the eigenvalue. Determinant of A is product of the eigenvalue. What is the trace? You can see the trace will be minus 4. Now you can see the sum is minus 4, fine. The sum is not minus 4. Sum is not a minus 4 because the eigenvalues are this and of this. So if you add them, again it's a minus 4 and it will be 4 minus 2 plus root 7 minus 2 minus of root 7. So if you add them, it will be 0. So now out of these two options, 1 is the correct one. Now how you can check that? The trace will be minus 4. So both are the correct. Now you can find the determinant. So what is the determinant of the first one? We can find it's a 6 minus 25 minus 1. It is my minus 3. If I just clear this, so minus 1 will be minus 3 minus 10, and plus of 2, it will be 5 plus 4. So what is that? It's a minus 19, it's a 13, plus of 13 is a 10, plus of 20. So it's a minus 6 plus 20, that is my plus 14. So is the sum is 14? No. Can this be the sum is 14? So this, so what is that? It is a square minus b square. So what is that? It's a 3, it's a 12. So again it will not be there. So you can check about their calculation again. It's a 6 minus 25 minus 3 minus 10, 5 plus 4. So it's a, sorry, it's a 9 to 18. So what is that? It's a 6 and 18, it's a 13. It's my 12. So what is that? It's 3, 4 into 3 is my 12. Is this is the right answer? It's a 36, but it's not the right answer. So right answer is my C is the correct answer. Which of the following is my linear? So a very simple, clearly see that xy, the degree of this, what is the degree of the xy is 2. So it is a non-linear. So this option is cancelled out. What is the linear is? If t of 0 is non-zero, then we call as that t is my non-linear. Fine. So what is the meaning of that? It clearly says the first option, what is the f0, 0, 0? It's a 4, 0, which is not equal to 0, 0. So this is a non-linear. So it means this is the only correct option, because if you substitute here, so only H is the right answer. F is cancelled, G is cancelled, all are cancelled. So right answer is only my C is the right answer. Now A is a real invertible matrix such that AB is equal to minus of BA. Then which of the following are here? So it is a invertible, means A inverse exists. Fine. Now which of the following is the correct option? Very simple example. You can simply take A is I, which is invertible. If I substitute here, B is my minus B. What is the meaning of that? Now your target is to find that trace. Trace of B is trace of minus B, which is minus trace of this. So what is that? 2 times trace of B is my 0. So it means trace of B is my 0. So trace of A, this B and C are cancelled. Now similarly, if I consider B is I, because A and B both are invertible, then you will get A is equal to minus A. So it means trace of A is my 0. So both are trace are my 0 is the simple right concept. Because you can think any of the example, but the simplest one is you can think about invertible. I is always invertible. Okay, again A is a n cross n. You can simply take A is my 2 cross 2. Rank is my 1. So if I take rank is 1, it means the one row is will be 0. So if I simply take here, you may think about like of this also, it is my say 2. Again rank of this is my 1. It satisfied this. Now what are the eigens values of this A? Eigenvalue of this is my 1, 0. What is the beta? Trace will be sum. So it is my here. Beta will be 1. What is the eigenvalue of the I plus A? So you can add them 2, 1. These are the eigenvalue of the I plus A. What is the alpha? Determinant is my 2. Once you know alpha and beta, check about this. 1 minus 2 is 1, not satisfied. 2 minus 1 is satisfied, but this is the counter example, we can't say it's a correct statement. Alpha 2 is less than 1 plus 1 is equality, it can't be less than, it's a cancel out. Alpha is greater than 1 plus 1, again it's not satisfied. The only left option is B is the right answer. You can think that it's a very simple if you think about any of the matrix which satisfies such kind of the properties. Okay, what is the rank of this matrix? So it's a 5 cross 5. It is not an easy task for you. You can expand them of the 5 cross 5. So what is the simplest manner? That's very simple. If you look about these last two row, if I substitute R5 minus, the last value will be 0, 0, 0, 0, 1. Fine. Similarly, if I take if I subtract this from here, it will be 0, 0, 0, 1, 1. Similarly, if I take like this way, 0, 0, 1, 0, 0, sorry, 0, 0, 1, 1, 1, 1. Same for here, 0, 1, 1, 1, 1, and the first value will be here. So what is that? This is the triangular matrix. And what are the eigenvalues of this? 5 eigenvalues. So product of them is my determinant is my 1, or otherwise you can simply see it's a lower triangular, so the determinant will be here. So these are my eigenvalues, or you can simply say, so determinant is a non-zero, so it means the rank of them will be a 5 is the right answer. Consider here A, B, C, D are the real constants. So this condition holds for all pair of the x and y. Then what is the value of the lambda? That's very simple. If you equate the coefficient on the both side, it will be a square plus b square. Fine. Now clearly sees a square plus b square is always be greater than 0 or equal to 0. Fine. So first option is cancel out. A and b are my real numbers, so there is no such lambda exists. That's a cancel option. Now it can be 0, it cannot be. Now how you can check about the second and third? Look at that. This option is greater than equal to 0. Fine. Another thing is it is for all. So what is the meaning of that? The left hand side, this pair is also be greater than 0 for all the pair of the x comma y. Remember, the word is all. If it is for all, what is the meaning of that? It's a greater than 0. It means it is my positive definite. Fine. Because if it is there exists some x, then it is not a positive definite. But he said for all the x, it means it's a positive definite. So once it's a positive definite, we can write the matrix Q as coefficient of the x square, coefficient of the y square, and it is always be the symmetric. So you can see the half of this and half of this. Now what is the property of the positive definites? The positive definite means the principal minors are always be greater than or equal to 0. Fine, because it's equality. So the first principal minor is lambda, which is greater than 0. Second principal minor is the determinant of this. So lambda minus 1 is greater than equal to 0. So what is that? The first line say here, second line say here. So what is the conclusion of these two cases? It means it is greater than equal to 1 is the right answer of this problem. So that's a simple straightforward quadratic form here. Remember, the word is for all. Okay, now look at this another one. A is a m cross n, B is my n cross n. So that's very simple. You can choose any value of the n, you can choose any value of the m. Make sure n is less than of this. If I consider this is 1, this is 2. Fine. So what is your target is? AB is my non-singular. It means your target is to prove it is my non-zero. AB is a singular. It means your target is to prove here it is BA non-singular and BA is a singular. So what is that? This is my 1 cross 2. This is my 2 cross 1. So think about any example. Simplest way, 1 cross 2. Fine. What is that? 2 cross 1, 1 comma 0. Fine. Now you can check about the AB. What is the AB? 1 0, 1 0. So AB will be my 1 cross 1. If you multiply them, 1 plus 0 is 1. So what is that? Determinant of them is my non-zero. So he said it's a 0. This option cancelled. We can check also for the BA. What is my BA is 1 0 and 1 0. So it's a 2 cross 2. So what is that? 1. First pair 1. Second pair it's a B. Firstly, sorry, it's a B. Firstly, you have to write a B. So B will be my 1 0. A will be my 1 comma 0. So what is that? 1 0 0 0. So what is the determinant of the BA? Is a 0. But he said it's a non-zero. So this option also cancel out. Now how you can check about the AB? And here we can take the another example. I can copy this for here. So what I can take another value, say B as reverse, say 0 1. Fine. So then I can check about the AB 1 0 and 0 1. So what is that? It's a 0 plus 0. It's a 0. So AB is a non-zero, is a cancel out, is the only right answer of this problem. If you want to check about this is a B, this is my A. If you want to check BA, it will be B, it will be A. So clearly say that 0 0 1 0. And what is the determinant of this AB? Is a 0. So this property here satisfied, this property here satisfied, while the rest of the property cancel out. So the right answer is my D is the correct answer. Okay, look about this one. A is my here. Then okay, what is that? Whenever you think about this equation, what is given, what is come in your mind? Yes, that's a Cayley-Hamilton theorem. So I can simply write this equation as 6i is a cube plus ba square plus 6a. So if I say lambda is the eigenvalue of this, so this equation will give you plus b here plus c minus 6 is equal to 0. Fine. This is the meaning of this. Now what is the b? B is nothing but my trace, sorry, b is nothing but my sum of the root of this equation, root of equation number 1. And we all know what is the root of this eigenvalues. Sum of the root is here. What is given to you? That is nothing but my trace of the matrix. So what is the trace of this? You can see. So it is 1 minus 2 minus 3. It is my minus 4. So sum of the root will be my minus b over a. Fine. So what is the answer is minus b over a is my minus of 4. Or you can see b is equal to 4a. So what is that? B is equal to 4a, not satisfied. B is equal to 4a, not satisfied. B is equal to 4a, not satisfied. B is equal to 4a, satisfied is the right answer of this problem. This is the sum of the root minus b over a. Sum of the root is nothing but the trace. Trace is the sum of the diagonal entries. So minus of the 4. So you can see b is equal to 4a. Only this option, because a is 1, b is equal to 4, is satisfied. Okay, again this is n cross n. You can think any of the a. So if I consider a is my 2 cross 2, b is also my 2 cross 2. Fine. So think about any of there. I can simply take a is my 1 0 0 0 and b will be my, I can simply take a is equal to minus b. So it is my here. So what is the rank of the a? 1. Rank of the b? 1. What is the rank of the a plus b? So what is the happen of the a plus b? A plus b will be my 0 matrix. So the rank of this will be my 0. Now check about that. This is a 0, a1 1, not satisfied. 0 less than 1 plus 1, satisfied, but this is a one counter example. Third option, 0 is minimum of 1 comma 1. 0 is equal to 1, not satisfied, cancel. Again is a 1, 1, maximum is again 1, but left hand side is a 0, so not satisfied. The only right answer is my B is the correct answer. So you can see there is a very, very simple are there once you think about this shortcut tricks. Now here A and B are the 2 cross 2, and here that's again very simple because we need a minus b, a plus b. Firstly we can think about a is equal to b. Is a 2 cross 2, I can simply take here because it's a 2 cross 2, either you can take I can simply take a is equal to b is equal to I. Fine. So what is the determinant of a? 1. Determinant of b? 1. So what is the first option? What is the determinant of 2a? So it is my 2 cross 2, so it is my 2 raised to power 2 determinant of a. Remember, alpha of a, n cross n is my alpha raised to power n determinant of a. So it is my 4. Left hand side 4 plus 0, this is 1 plus 1, not satisfied. This is my 4, this is 0, 2 minus 2, not satisfied. 4 plus 0, 2 plus 2, satisfied, but this is a one counter example. We have to discard this option as well. 4 minus 0, 2 minus 2, cancel out. So the right answer is only my C is the right answer, because here they are only talking about the 2 cross 2. You can think about any of the 2 cross 2. You may think about here as well, but that will take you a lot of the calculation. So I can simply take A and B as a I matrix. Okay, A is my 5 cross 5 such that characteristics polynomial of the A inverse are same. So what is the meaning of that? It means the eigenvalue of this matrix A and the eigenvalue of this matrix same are same. So when both the eigenvalues are same, you can simply take one. If I simply take I is my identity matrix, it's my 5 cross 5, then what is the A square? A square is also I, and what is the A5? It is also I. Then what is the trace of the A square? So if it is a 5 cross 5, so this is my I, so trace of them will be my 5. But he said trace of the A square is 1, is a cancel out. Trace of the A5 is again 5, so this option is also cancelled. What is the determinant of the A square? So it's only the diagonal entry 1, it's a 1. He said also 1, but we can't say it's a correct option because it's a counter example. Determinant of the A5 is also 1, so we can't say about this option. Now look at the another example. We have to think about all the eigenvalues are same. If I consider this as a minus of the I, so what is the eigenvalue of the A? Minus 1, minus 1, minus 1, minus 1. What is the eigenvalue of the A inverse? 1 over minus 1, 1 over minus 1, both are same, so they are the same. What is the A square? Is a plus I. What is the A raised to power 5? Minus of the I. What is the determinant of the A square? 1. What is the determinant of the A5? Minus 1. But he said determinant is plus 1. So based on this counter example, this is a cancel out. So only one option left. So that is my correct option. Okay, next one is which of the following statement is my true? Determinant, all they have the determinant. Look at this option. This is 0 for all the t belongs to the R. If I simply take t is my 0 for the easiest calculation, this value will be 0, this value will be 0. What is the determinant of this? It's a triangular matrix. It's a 1 which is non-zero. So this option is cancel out. Fine. Now look at that. Determinant is 0 for infinitely many, exactly 2, polynomial of degree 3. So what I can expand them. What is that? 1 minus of t square minus of t 1 minus 0. So 1 minus t square minus of t. So what is the degree of this polynomial? Degree is my 2, but he said degree 3, cancel out. This is 0 for infinitely many t. That's a wrong statement because this is 0 for exactly, because it's a quadratic, so we can see exactly of the 2 roots of this t. So exactly 2 value is the correct option. Rest all the 3 are cancel out. Right option is the fourth option is the correct one. Okay, look at this one. R of n is my standard inner product. V1, V2 are my orthonormal. Is my orthonormal. Fine. A again is a n cross n. So firstly I can take as a 2 cross 2. So it means my V1 and V2 are my orthonormal. Fine. Then the matrix A is formed by V1 and V2. Okay, what is orthonormal is? That is V1 dot V2 will be 0 and V1 square will be 1. Fine. Like of this matrix, if I simply say 1 0 0 minus 1, so clearly say that V11 is my 1, square of them is 1, square of 1 is 1, dot product will be 0. Now if you consider the matrix A is here, so fine, that's simple. What is that? If V1 V2 are my orthonormal, fine, then what is the column vector? These are, what is the matrix corresponding to them? This is my orthogonal matrix. You can easily construct by using the Gram-Smith process. So once A is my orthogonal matrix, what is the meaning of that? A into A transpose is my I. That's a simple property. So A into A transpose is the I is a correct statement. Based on this counter example, you can simply say what is the determinant is minus 1, but he said plus 1 is the wrong answer. What is that? Is that A is A transpose? That's the correct, but orthogonal property not satisfied. A and A inverse are same. In this case is also same, but it is not satisfied the orthogonal property. So the right answer is only my C is the correct answer. Okay, V is the vector space of the continuous function over the closed interval 0, 1. W is my subspace of the sin x, cos x and the tan x. Fine. Then your target is to find the dimension. What is the meaning of the dimension? You have to find the number of the linearly independent vectors. How you find the number of the linear independent vectors in case of the function? We will check about the Wronskian. Fine. So what is the Wronskian? If you have the three different function like f1, f2, f3, so you can take the first derivative, you can take the second derivative. Fine. This is my 3 cross 3. If it is 0 for all x, then we call as the LD. If it is a non-zero for all x, we call as the Li. Fine. So once we know the Li, then we call as the Li dimensions. So since firstly we can take the derivative sin x, cos x, tan x. So what is the derivative is cos x minus sin x tan secant square x minus sin x minus cos x 2 secant x into secant x tan x. So secant square tan x. So now we all know in order to check for the linear independent, if Wronskian is 0, then it will be 0 for all the domain. It will be 0 for all the domain. Otherwise it will not be there. So if you take any of the pair, so you can choose any of the value of the x. If we prove that value, the Wronskian is non-zero, it means it is non-zero for the closed interval of this. The easiest way we can took as x is equal to 0. But you can see when x is 0, the function 0, 1, 0. So it is not be there. So you can choose any of the value. The easiest way you can choose as a pi by 6. So but it will give you as a root of this. Easiest way you can take as a pi by 4. So tan pi by 4 is 1 and here. So what is that? This is 1 by root 2. It is 1 by root 2. It is 1. Cos is 1 by root 2. This is minus 1 by root 2. Secant square is 2. Sin is minus 1 by root 2. It's minus 1 by root 2. It's a tan 45 is 1. Secant square is my 2. So 2 into 2 is my 4. Now how you can solve the determinant? You can simply add them. This give you a 0. This will give you a 2 times. This give you a 6 times. You can subtract them. This will give you a 0. This will give you a 2 times. This will give you a 1. Then you can make them. You can subtract this pair. This will give a 0. This will give you a 5. So these three values will be 0. So what is the product of them? 1 by root 2 minus 2 by root 2 and of 5, which is my non-zero. So it means these three vectors are my Li. So what is the dimension of this? There are the three vectors. So dimension is my 3 is the right answer. So that's a very simple. You can check about the Li. If Li is not be there, then dimension will be less than of the 3. Okay, look at this another concept. P of A is the characteristics polynomial of A. Then P of A inverse is the characteristics polynomial of the A inverse. Which of the following is a constant? What is the characteristics polynomial? This is my characteristics polynomial of the matrix A. Fine. What is the characteristics polynomial of the A inverse? This is the characteristics polynomial of the A inverse. Fine. Now what the statement said, if you take the difference, it will be constant. When it will be constant? When it is independent of the variable lambda. So when it will be here? So only when both the values are same. Then only if you subtract them, it will be cancelled out. And then it will be left as here as a constant. So what is the meaning of that? What is that? If I consider A has the eigenvalue lambda 1 and lambda 2, what is the A inverse eigenvalue? 1 over this, 1 over this. So what is the trace of this? This is, what is the trace of this? Here. So if you take the LCM, what is the meaning of that? This will be 1. So what is the meaning of that? Or you can say, what is that? If A has the eigenvalue this, product of them is 1. That means determinant will be 1. So check about the 4 option whose determinant will be 1. So 12 minus 6, not 1. 9 minus 8, 1, correct option. 12 minus 6, not 1. 8 minus 9 is a minus 1, but we need a plus 1. So the right answer is only the third option is the correct answer. Okay, look about this another question. So again, it is given to you as A is n cross n. So I can simply take 2 cross 2. Fine. A is my 2 cross 2. Such that the sum of the each element of the row is my 2. This is my 2. And sum of the, if I take as a B, sum of the each column values, sum of the each column is my 2. So firstly, check whether this property is satisfied for the I. 1 0 0 1. No, sum is not be a 2. So what you can do? I can simply take is a 0 2, sum is 2, 1 1 satisfied. Okay, and we need a transpose also. So if I take same as thing, so ultimately what I can think is here. Fine. Now, or you can simply take one simplest way is you can simply take as 1 1 1 1. Column sum, row sum are same. Now, what is the eigenvalue of this? What is the eigenvalue of this matrix? So clearly say that rank is 0, so one eigenvalue is 0. The sum of the eigenvalue is my 2, so the other value is my 2. Fine. So A has the eigenvalue 0, A has eigenvalue 2. What is that transpose? We all know that transpose has the same eigenvalue. Fine. What is the eigenvalue of the is 1 1. What is the eigenvalue of the A is equal to B? So this is what is the B of A transpose is B square. So eigenvalue of this is my B. What is the eigenvalue of the B square? 0, 4. So now your target is to prove which one of them is a necessary singular. Singular means determinant of this answer will be 0, or at least one of the eigenvalue is my 0. Fine. So these are the pair. So clearly says that if you take 1 minus 0 and 1 minus 2, none of the eigenvalue is 0. So first option is cancelled out. Same for here. What is the AB? AB is nothing but the B square. So none of the eigenvalue is 0. Look at this one. 1 comma 1. What is the eigenvalue of the AB? AB is nothing but my B square. So B square is my 0 comma 4. So 1 comma 1. This is my 0 comma 1. So it's a 1 comma 0. One eigenvalue is there. So but this is a one counter example. We can check over the BA transpose. This again a B square. So out of these two options we will check about that. So this first example, that's enough to discard for the first two options. Now how we can check for the other options? So I can look about this example. So A transpose is nothing but B. So what is that? This pair is my 1 minus half B square. What is the eigenvalue of the B? Eigenvalue of the B is my 2 comma 1. What is the eigenvalue of the B square? 4 comma 1. So if I substitute here, these are the eigenvalue of the 1 comma 1. Eigenvalue of this is 4 comma 1. So it is 1 minus 1, 1 minus 1 by 4. It is still 0. So we can't discard them. So we will check about the AB. If I A and this, what is the AB? So it is my 4, it is my 2, it is my 2, and it is my 2. How you can find the eigenvalue? You can find this here. This is 6, 8 minus 4. So this is the plus minus of here. So otherwise I can check about the determinant of this matrix. What is that? I minus 4AB. So 1 minus 1. This is second component is 0. So 0 minus half. 1 by 4 of AB. 0 minus 1 by 4 of AB half. This is 1 minus 2 by 4. So this is my matrix of this. What is the determinant of this? This is a 0. So this will be 0. This is a non-zero. So it is 1 by 4, which is a non-zero. So for the singular, this matrix must be 0. So this option is cancelled out. I have taken AB. So the only rest option is D is the right answer of the problem. Okay, look at the linear transformation. A linear transformation T rotate clockwise through the 90 degree, then of this. That's very simple. What is the 1 comma 0? You can think about the XY pair. This is my 1 comma 0 pair. 0 comma 1 is my here. Now you have to rotate through the clockwise. This is my clockwise 90 degree. This point, if I call this is my A, this is my B. So this point B will be my here. This is B dash and A will be my here. I call as a dash. So what is the coordinate of the A dash? This point on this axis it will be 1 0. What is the coordinate of the B? On this y axis, x component is 0, y axis is minus 1. Fine. So what is the answer? So this map 1 0 will map to the 0 minus 1. 0 1 will map to the 1 0 is the right answer. You can see only this option is there. 0 minus 1, it's a minus 1, cancel out. 0 1, but we need a 0 minus 1. 0 1, but we need a minus 1 is the wrong answer. Remember, whenever you are talking about the linear transformation, vectors are always written in the column vector. If you written this vector as a row matrix, then you can see this option is correct, but that's wrong. Always written the matrix in the column wise. So the right answer is my B is the correct option. Okay, what is that? This is the primitive root of the unity. Omega raised to power 5 is my 1. Fine. Okay, V is my here. This is some certain matrix. V of here is this V A V transpose. Fine. So clearly say this is my symmetric matrix. Fine. Then for the particular pair of the W, what is the value of this of here? So what is that? This is nothing but my here. Fine. Now what is the shortcut tricks? Otherwise what you can do, you can write as a matrix A, you can write that transpose as 1 minus 1 1 1 and then you can multiply them, but there is no need. How you can multiply them? Think about that. This is matrix. What is that? This is my quadratic nature. Once this is symmetric, it's a quadratic, so it is always be the quadratic form. So how you can multiply them is a quadratic form. When you multiply them, what will be the nature? The nature will be, this is my 1 1. So you can pair, first pair 1 into 1, that is 1 into 1 of xi square. Fine. Second is a 0, so rest of the all are 0. This is my A2 2. So second element and again the second element. So this is my minus 1 of xi mine. Like here, if I say this number is my 1 or say 4. So what is that? If you multiply them, it will be A1 4. The first pair 1, fourth pair will be 1. That is the meaning of this. Similarly, the third pair is A3 3. So 1, third pair is my square of this 1 A3 3. Fourth pair is xi. Fourth pair A4 4 1 1. Fifth pair is minus 1 of xi square. So what is the answer of this? This is my, so what is the answer is xi raised to power minus 2, xi raised to power minus 1 xi square. So what is the meaning of that? If you simplify them, if you take the LCM, it will give you, or xi raised to power 5 is 1. So what is that? It is xi cube, xi square, 1 xi square. What is that? The sum of the primitive fifth root of the unity is always be the 0. So what is the right answer of this? 0 square root of 0 is my 0 is the right answer of this. Sum of the primitive root is 0, product is my 1. This is again the same. This is in the year 2012 and this is the year 2011. Again it's a primitive cube root of the unity, so it is my 1. Again this is symmetric and this is my quadratic. Fine. So what is the answer of the W of this? It is my root of the A11. So first element is repeated 2 times, xi raised to power minus 1. This is my A22. So second element repeated 2 times of 1 plus A33 2 times of this. So what is that? This is xi raised to power minus 1 xi 1. Xi cube is 1, so xi minus 1 is xi square. So what is that? This is sum of the cube root of the unity, that's my 0. So again answer is 0 is the right answer, because we all know if omega is the cube root of unity, this value will be 0, omega cube is my 1. Or you can simply see, I can write this number as of this manner also. Fine. So 1 is the cube root of unity. This must be 0. So it's the right answer of this problem. Okay, now you have to find the trace. So we will look about the eigenvalue. So firstly we will check about the eigenvalue of this. What is the eigenvalue of this matrix? Eigenvalues are 2, 2 and 3. Then what is the eigenvalue of this matrix? 2 raised to power 20, 2 raised to power 20, 3 raised to power 20. Why? If A has the eigenvalue lambda, A raised to power n has the eigenvalues here. Then what is the trace of this matrix? You can simply add them. So this is the right answer. So you can write as 2 into 2 raised to power 20 plus 3 into 2 raised to power 20 is the right answer. So this option cancel, this cancel, only the C is the right answer of the problem. Okay, T is the mapping from P2 to P3 defined by integration 0 f dt plus f dash. Fine. Then the matrix associated with here. So this is 4 cross 3, this is 4 cross 3, sorry 3 cross 4, 3 cross 4, 4 cross 3, 4 cross 3. Then what will be the matrix size? That's very simple. What is the size is? If I call it, this is a dimension n, this has the dimension m, then the matrix is always be the range multiplied by codomain here. So what is the dimension of the P3? P3 is a polynomial of degree less than or equal to n. So what is the dimension of this? Less than or equal to 3. So the dimension of this will be my 4. Dimension of the P2 will be my 3. So this matrix will be my 4 cross 3. So first option, third option cancel out. Fine. Now look at that. We can take any of the bases from the P2, that is a 1. If I substitute here, what is the integration of the 1 dx? What is the derivative is 0. So it is x. So if I consider the basis of the 4 cross, so 1 x, x square, x cube. This is my x, so that's the second. So second value will be 1, rest all are my 0. So first column satisfied. If I take the second basis as a x, then it is x of dx plus f dash, that is a 1. So integration is x square by 2 minus 0 plus 1. So you can see 1 is a constant. So 1 is a constant. X square. So this is my half. This is 0. This is 0. So this pair satisfied. This is not satisfied. Right answer is my B is the correct option. Remember always your target is to discard the options. Okay, V is the vector space of the polynomial less than equal to 10. So what is the dimension of the V? 11. Because whenever it's a polynomial of degree less than equal to n, then their dimension will be n plus 1. Define the mapping as T of Px is my derivative. Then you have to define a mapping from V to V. So what is the dimension? What is the size of this matrix? Dimension of V is 11, so it's a 11 cross 11. Let A is the matrix associative. Okay, fine. So firstly, if I take 1, what is the derivative is? If I write here as a 1x x square, the last value will be my x raised to power 10. If I take as a 1, the derivative will be 0. So 0 is a constant, rest values are my 0. If I take as a x, the derivative will be 1, that's a constant value, so it's a 1, rest all values are my 0. If I take as x square, the derivative will be my 2x, so 2x is my here, rest all values are my 0. X cube, 3x square, so x square is my 3, rest all values are my 0. Similarly, if I take x raised to power 10, it is my here, so x raised to power 9 is my 10, rest all values are my 0. So what is the meaning of that? You can see the diagonal values are my 0. So what is the meaning of that? Trace of this matrix is my 0. The determinant of this matrix is my 0. Okay. Now trace is my 1, cancel. Determinant is my 0. That's correct option. There is no m such that a raised to power m is 0. So what is the meaning of that? What is the eigenvalues of this matrix? 0, 0, 0. So that means all the eigenvalues are my 0. Once all the eigenvalues are 0, what kind of the matrix? So this matrix is my nilpotent matrix. Fine. So once there is a nilpotent matrix, it means there exists at least one m, so that a raised to power m will be 0. But he said there is no. So this is cancel out. A has a non-zero eigenvalue, but all the eigenvalues are 0. So this option is also cancel out. Okay. So here another tips related to that. If A has all the 0 eigenvalue, what is the meaning of that? A is my nilpotent matrix. Once A is my nilpotent matrix, then it is not a diagonal matrix. So but right now they are not talking about the diagonalizable matrix, but if they are ask you like A is diagonal matrix, so then again this option is cancel out, because whenever there is a nilpotent matrix, it can never be a diagonal matrix. So in this case the right answer is my B is the correct answer. Okay, V is the vector space of the polynomial f of x comma y with degree less than equal to 3. Okay, now it's a polynomial of the two variable. What I discuss in here is whenever a polynomial of degree 1, then the dimension is n plus 1. Like here, whenever it's a polynomial of degree n, then their dimension is n plus 1. But whenever there is a polynomial of degree x plus y, that is a function of the several variable and whose degree is less than equal to n, then their dimension will be always n plus 1, n plus 2 divided by 2. Fine. So now in this case it is a strictly less than n, but it not satisfy the equality. So I can return this number as less than equal to 2. So what is the dimension of the f? So n is my 2, so it is my 3, 4 over 2, that is my 6. So it means dimension 6 means it has 6 elements in the basis. So what are the 6 elements? 1 x, y, so 3, one is x square, xy, y square. These are the elements of this. Now the rest of the part is similar. You define the mapping on the V such that it is partial derivative. So now that's over. Now it's a 6 cross 6 because the dimension of this is my 6, dimension of this is 6, so it's a 6 cross 6. I written as x, y, x square, xy, y square. So look at that. If I take the first, what is the partial derivative of 1 is 0. So 0 is the constant, rest all values are my 0. If I take this, partial derivative is my 1, so 1 is again constant, it's a 1, rest values are my 0. What is the partial derivative of y? 0. It's a constant is 0, no, there is no coefficient of the x square here. What is the derivative is? 2x, that's the coefficient of the x. So this is my coefficient of the x, rest values are my 0. Coefficient of the x, partial derivative is y, so y is my here 1, rest values are my 0. What is the derivative is with respect to x? 0. So y is 0 is a constant here, rest all values are my 0. Fine. Now again you can see the diagonal entries all are my 0. So what is the meaning of that? Determinant of this matrix A, or I call this as a T, then the determinant of T is my 0, trace of this T is my 0, all eigenvalues are my 0. So again it's a nilpotent matrix and same. So T is invertible, cancel out because determinant of T is 0. Rank, how many number of the non-zero rows? So you can see 1, 2 and 3, these are completely 0. So the rank of the T is my 3. So at least 4, cancel out. At least 3, so that means greater than or equal to 3. So equality is satisfied. So this satisfied. Nullity, how you can find the nullity? By using the rank nullity theorem, n minus rank of T. So n is my 6, 6 minus 3, because this is my 3, so it is my here. So nullity will be 3, but he said nullity is at least 3, at least greater than equal to 3. But now you can see, if I say it's a at least, it means it's a greater than equal to 3. If I substitute here, it is less than equal to 3. So nullity will be at the most 3. So this option is cancelled, this option is cancelled, this cancelled. The only right option left is this is the right answer. Because rank plus nullity is my dimension. So dimension is 6. Rank is, if rank is my at least, then this is the right answer. But at least is also satisfied. It is 3 also. Equality is also satisfied. Sorry. So this is also the right answer. This nullity is also be the right answer. Because if I say rank is my 4, then definitely it's a less than. No, it's nullity is less than at least 3. It's a greater than sign. But we need a less than sign. So definitely this is not right answer. Right answer is C only. That's correct. Okay. S is a mapping from. Okay, again this is a vector space. What is the dimension of the S? Is all the polynomial of degree at most 3. At most 3. Equality is there. So the dimension is my 4. So is a S from dimension is 4 cross 4. So matrix will be 4 cross 4. How you define the matrix? Is my x plus polynomial of the x plus 1. Okay. So it will be my 4 cross 4. Degree of 3. 1x, x square, x cube. These are my here. Firstly, I can take as a 1. So if I take p of x is my 1. What is the p of x plus 1 is again 1. So it is 1, 0, 0, 0. So this option cancel. First column is here. This option cancel. Two options left. So look at the second column. We will get the right answer in the next one. If I take p of x is my x. What is the right hand side is? If p of x is x, it will be x plus 1. So this is my constant. Constant will be 1. X will be 1. Rest all are 0. So 1, 1, 0. So this is 0, 0, 0, 2. Cancel out. All these 3 options cancel. Right answer is my. Here is the correct option. If you want to check for the other, but there is no need. So if I take as a x square, this number will be x plus 1 whole square. X square plus 1 plus 2x. Constant will be 1. Coefficient of the x will be 2. Coefficient of the x square is 1. Here 1, 2, 1. Similarly for the cube is the right answer. Okay, W is the vector space of the degree at the most 3. So again, dimension of W is my 4 at most. W is the mapping. T is the mapping from derivative. P dash is the derivative of P. So again, what is that? This is my 4 cross 4. What is that? It's 1 x, x square, x cube. So what is that? If I take P of x is my 1, derivative will be 0. So 0 is a constant. Here all the values are 0. So this option cancel. This is a correct. This is correct. This may be correct. If I take P of x is my 1. X. What is the derivative is? 1. It's a constant. Here rest all values are 0. Remember written in the column wise. So this option is cancel out. This option may be correct. This option may be correct. If I take the third option, x square. What is the derivative is? 2x. That's the coefficient of the x. 2. Rest all are 0. 0, 2, 0, 0. 0, 2, 0, 0. 2, 0, 0. So this cancel. Only one option left is the right answer of this problem. You can see within a 10 seconds you can solve the problem. Okay, T is the mapping from R4 to R4 defined by T of V is AV. Which are the for which choices of the A given by image of T and image of T square has the value 2 and 1. What is the meaning of the image? Dimension of the range space. That is the meaning of this. What is the dimension of the range space? That is the rank. That is the meaning of the rank. So I can written this number as rank of T is my 2 and rank of T square is my 1. So we have to check this option. What is the star means? Star represents the non-zero entries. Fine. So firstly we will check which of the following has non-rank 2. What is the definition of the rank? Rank of is number of the non-zero rows or the number of the non-zero columns, or you can say the dimension of the row space, or you can say dimension of the column space. So look at the first column. There are 2 zero values, 2 non-zero. So the rank is my 2. These are again rank is my 2. These are the 2 non-zero values, 2 zero values. So rank is my 2. two non-zero values, rank is my 2. So first property is satisfied in each case. Now the only target we will check for the rank of the t-square. So how you can multiply them? So if I say this is my 4 matrix, this can be anything, this can be anything, this can be anything. Fine. How you can find the a square? So one way is you can write this matrix here, but how you can multiply them, that's a simple shortcut fix I will tell you. The two columns are 0, so you can write this value as a 0 as such. Now look at that. This is the first row. This is the first row. This element is my A13. First row, third column. So you can write the first, that's a third and fourth are my non-zero elements. So I can take the first row, third column. First row, third column. If you multiply them, the value will be 0 because the third non-zero elements are there. Similarly, if you multiply this as A14, first row, fourth column, the first two value will be 0, the third value will be non-zero, so it has one non-zero element. Similarly for the other pair, this is a A23. This value multiplied by here, it's a 0. This value multiplied by here, this is a third element non-zero. Similarly for here, this is the only fourth position is a non-zero. So if you look about that, this is a 0 and this is a 0. And the last row is a 0, so it's a 0. So what is the rank of this? Clearly sees you can, how many 3 0 elements. So what is the rank of that a square is 1. And this is what we need. So this first option is the correct option. Now look at the second option. Look at the second option. Here is this value is my non-zero. Fine. So how you can multiply them? So again, how you can easily multiply them? Because there is only one correct option. So first we can easily get, but we will see the rest of the option also here. So first column, this value. So this is a third and fourth option. So third and fourth will be 0. This to the here, third and fourth is a non-zero. Second or third and fourth is a 0. This is a non-zero. Third and fourth 0. This is a non-zero. Third and fourth, this is the last option. This is a A. This value will be non-zero. This value will be non-zero. So what is the rank of, now there are the two non-zero rows are there. So what is the rank of this? There are two non-zero rows. So the rank will be a square 2, but we need a 1. So this option is cancelled out. Similarly, how you can multiply this matrix? First two columns are 0. So you can write as directly 0. First two row are also 0. You can write directly as here. Now the two values. This value is my A32. Third row. So only the fourth value are there. Non-zero. Third row, fourth column. Third and fourth values are 0. So it's a 0. It's a A4, 3. Fourth row, third column. So the last value is a non-zero. This value will be this into this is a non-zero. Again you can see that two values are the zeros, two rows are non-zero. Rank of this is my 2, but we need again 1. This option is cancelled out. Now you can see about this again. So first two values are 0 again. So we can I can write for you here how you can multiply them again. So first two columns are 0. First two rows are 0. So I need to only compute this value. So this value multiplied by this value. So third and fourth, it's a non-zero. Third, this value, so again non-zero. This value, non-zero, this value non-zero. So now, what is that? The rank, if you, again the two non-zero rows, if you use the row reduce, it can be 0. If you think about that, its value is a 1, 1, it's a 2, 2. If I make them, it's a 0 as well. So there is a 1 non-zero row. But if the value will be 4 and 7 and say 2 and 8, then again will be a rank of this will be my 2. So in this case, either the rank 2 or the 1, but we always need a non-zero entries. So this option is also cancelled. Right option is only A is my correct answers. Okay, look at that. X and Y are my Li. It is given to you. There are some parameters of given to you. V is the span of X and Y. You know what is the meaning of the span? Span means basis. You can write in terms of the linear combinations. It's not a basis. you can write in terms of the linear that is the element of the V is write as a linear combinations of X and Y. What is that tips? What is the concept for the span? If V is my U, V, W, what is the definition of the span? That is the definition of the span. V, X and Y. This must be 0. That's a simple shortcut text for you. What is the V? V is the element of the, so U, V, W. What is the element of the X? X1, X2, X3, Y1, Y2, Y3 is my 0. Now we can expand them and check which one is the relation. So if you expand them, it will be X2, Y3 minus Y2, X3. X2, Y3 minus Y2, X3 is a delta 1 of U minus of V, X1, Y3 minus Y1, X3. Is there any value? X1, Y3, Y1, X2. So minus delta 2. So you can see plus W, it's a X1, Y2 minus X2, Y1 is a delta 3 is the required answer. You can see the first option correct. Minus delta 1 cancel out. It's a plus, but we need a V as a negative sign. V as a negative sign, but it's a plus. Right answer is only my A. So this is the property of the span. That's a simple tips for you for the span case. Okay, V is the vector of the dimension 3. Then which of the following is there? That's a linear transformation. As I mentioned you always, whenever this is a non-zero, it is called as the non-linear. Fine. Okay, it's an ordered basis. We know what is the ordered basis is 1 0 0 0 1 0 and 0 0 1. Whenever there is an ordered basis, whatever the column vector, the first column is corresponding to V1, second is column corresponding to V2, third is my V3. Fine. So now you can see this is a non-zero. Fine. So T of V is non-zero. V1, because we all know 0 map will belongs to the 0 map. So V1 plus V2, is it a 0? 0 minus 3, 3, which is a non-zero. Sum of them, V1 plus V2 plus V3, 0. V1 plus V2 plus V3, 0. V1 plus V2 plus V3, 0. So 0 maps to the 0 is a satisfied. V1 plus V3 is equal to V2. What is a V1 plus V2? It's a 1. First one is not satisfied. Sum of them will be a minus 1, but it is a plus 1. Similarly, it's a 4, it's minus 5. But here is the opposite of them. So it's a minus of V2, but it's a plus, it's a cancel. Right option is the third option is the correct answer. Okay, which of the following is not diagonal? So first of all, what is the tips for you? When you can say it's a diagonal, when you find the eigenvalues, if all the eigenvalues are distinct, then it's a diagonal. Second is, if you find the algebraic multiplicity of the lambda, if it is same as that of the geometric multiplicity of lambda. How you can find the geometric multiplicity? This is my n minus rank of a minus lambda I. Third one is, if you prove that the minimal polynomial is in the linear factor, then it's a diagonal. Now we will check about this first case. What is the eigenvalue of the first option? 2, 2 and 3. This is a distinct, but this algebraic multiplicity of the 2 is my 2 times. How you can find the geometric multiplicity? Here, dimension is my 3 cross 3. So 3 minus rank of a minus lambda is my 2. So what is that? A minus 2i, 0, 0, 1, 0, 1, 0, 0, 0, 2. So what is the rank of this? You can see, I can easily make this value as a 0, R2 minus A. So this value will be 0 if I take this value as of this. So what is the rank of this? Rank is my 2. 3 minus 2 is 1. So algebraic multiplicity and geometric multiplicity are not same. So it means this is not diagonal. Here you can, it is a note. So it is not a diagonal. So we need also note. So it means this is the right answer. Look at there. You can easily find the eigenvalue. So one eigenvalue is 0 because determinant is a 0. Trace is my 2. So second eigenvalue is 2. So you can see these are my distinct eigenvalue. So it is a diagonal matrix. But we need a note. What is that? So lambda square minus 5 lambda, 4 plus 2, 6. So clearly say that 3 and 2 are my eigenvalue, which are the distinct eigenvalues. So it is a diagonal matrix, but we need a NOT. It's a cancel out. Look at this third option. Eigenvalues are my 2, 3 and 3. These are distinct eigenvalues. So we will check about algebraic multiplicity of 3 is my 2. What is the geometric multiplicity of the 3? So 3 minus rank of a minus 3i. So what is the rank of a minus 3i? Minus 1, 1, 0, 0, 0, 0, 0, 0, 0. So rank is my, what is the rank of this matrix? 1. So 3 minus 2 is 2. So once both are same, so this matrix is my diagonal, but we need again a NOT. So this option is cancelled. Right answer is only A is my correct option. Okay, you have to find the trace of the A. So if I found the eigenvalue of the A, here what is the eigenvalue of the A square? These are my eigenvalue of the A square. Then how you can find the eigenvalue of the A square? That is the simple tips for you. Fine. Now if you substitute here, trace is my 3, determinant is my 1. So what is that? It will be minus b plus minus b square minus 4ac over 2. So trace will be 3 plus 5 by 2, 3 minus root 5 by 2. So what are the eigenvalue of the A square? So it's a 9 plus 5 plus 6 root 5 over 4, and second is 9 plus 5 minus 6 root 5 over 4. So what is the trace of this? You can simply add them. 4 will be LCM, 14 plus 14, 28 by 4, 7 is the right answer of this problem. Because you can see, easily see, this will be cancelled out. 9 plus 14 by 4 is the 8 answer. Okay, consider the two statement matrix M4. This is the basis of the row. Row means that is the dimension of the rank, and this is a nullity. So this is a nullity. Statement 1 and 2 are there. That's a very simple. Whenever there is a rank and nullity, what theorem is applicable? Rank of A plus nullity of A is dimension of the vector space. So look at the first case. Dimension is my 4. What is the rank? These are the bases. So what is the dimension of this? It's my 2. Nullity is my 1. Is it correct? They are not. So this option is cancelled. These are column vectors. So we all know rank is nothing but my dimension of the row space or dimension of the column space. So you can see what is the dimension is 2. Rank is my 2. Nullity dimension is my 2. So 2 plus 2, 4. 2 plus 2 is 4 is a correct statement. So first is my false, second is my correct. First is my false, second is correct. First is true, cancel. Both the statements are false, cancel. Both are true, cancel. Right answer is my A is the correct option. Okay, M is my 3 cross 3. 1 is eigenvalue. So it has a 3 eigenvalues. One eigenvalue is given to you as a 1. So you need to find the 2 eigenvalue. What is the shortcut tricks? How you can find the eigenvalue? Trace of them is 5, but you can see what is the column sum? Is a 2, column sum is 2, column sum is 2. What is the row sum? Minus 1, 2, 5. You can see the column sum is same whenever either the row sum or column sum are same and say k, then one of the eigenvalue will be my k. In this example, what is the column sum is my 2, so one of the eigenvalue will be my 2. So we know the sum of the eigenvalue will be the trace will be 5. So once we know the other eigenvalue will be my 2. So the 3 eigenvalues are 1, 2, 2 are my eigenvalues. So minus 2 is the eigenvalue, cancel out. 3 is the eigenvalue, is a cancel out. Now again, how you can check whether it's a diagonal or not? We will apply the same rule. We will check the algebraic multiplicity and the dimension. So this is a single So algebraic multiplicity of the 2 is my 2. Geometric multiplicity of the 2. So how you can check? N minus rank of a minus 2y. So if I take a minus of 2y, what will happen? Minus of 2, minus 1, 0. 1, 0, minus 1. 1, 1, 1. Fine. So what is the rank of this? If I subtract them, here 1, 0, minus 1, it will be 0, it will be 1, it will be 2. If I multiply by 2 and subtract them, so it will be my 0. If I 2 subtract them, same. If I 2 subtract them, it will be my minus of 2. So if you can see, so it will be 0, minus 1, minus 2, 1, 0, minus 1, 0, 1, 2. If I add R3 plus R1, this value will be my 0. So the rank will be my 2. 3 minus 2 is my 1. So both are not same. So it is not diagonal. So it means M is diagonal, cancel out, only right option is here. So again, how you can check that? Because 1, algebraic multiplicity of 1 is 1. So since it's a distinct value, so geometric is also 1. What is the algebraic multiplicity of the 2 is my 2. Geometric multiplicity of the 2 is 1. And the eigenspace as each has dimension 1. What is the eigenspace is? Eigenspace is called as geometric multiplicity. So you can see each has the 1 eigenvalues. But there is no need to check the third option. The rest of the 3 options cancel out. So the right answer is third is the correct answer. Okay, next option is C. T is my mapping from n greater than equal to 2. I can simply take n is my 2. Fine. So the mapping will be my 2 cross 2. 1 is the only eigenvalue. 1 is the only eigenvalue. So this is the one counter example. That is nothing but my I. So I can simply say 1 and 1 is the only eigenvalue. Then there does not t raised to power k. Okay, fine. What is that? Whatever the power of the k, you can see this is always 1 or I. But he said not equal to. This option is cancelled. Fine. Now I have taken n is equal to 2. So this value will be my 1. So I have to check whether t minus I or 0 or not. So since this value I have taken as 1i, so it will be 2, but this is a counter example. Look at this option. If 1 is the only eigenvalue, if 1 is the only eigenvalue of the t, what is the meaning of that? If t has the dimension 2, then it's a 1 cross 1. If t has the dimension n, then it has 1, 1, 1 and here. So it means the characteristics polynomial will be my of this, and the Cayley-Hamilton theorems will say this value will be 0. So this is the correct option. Look at this one. I can return this number as into this of t minus I. So since this number will be 0, so if you product them, this is also be a 0. How you can check about this option? So now in case of the 2 cross 2, we can never think about that. So think about n is equal to 3. Say 3 cross 3. This is my here. If I consider this is my alpha, this is my beta, this is my gamma, then clearly says eigenvalues are my 1, 1 and 1. Now if I take n is my 3, what will be my n minus 1, 2. So it means I need to compute t minus I whole square. Fine. So firstly, what is a t minus I? 0 alpha beta, 0 0 gamma, 0 0 1. I have to multiply this by here, and we need to prove this will be a 0. Okay, so again, as I discussed you in the previous, how you can multiply, the first column will be 0. This is my A12, first column here. So you can see it's a 0. This value multiply, or you can write this number as here, this is a 0. Third number will be alpha gamma. Fine. So clearly say that this will be a non-zero because you can choose any value. So this value will not be a 0. So this option is a 0, is a cancel out. So right answers are C and D are the 2 correct options for this example. Okay, again A is my n cross n. I consider as a 2 cross 2. such that the set of all the non-zero eigenvalue has exactly R element. What is the value of the R? R can be anything, so R can be, I think, as a 1. What is the meaning of that? If I consider the 2 cross 2 matrix, the set of all the non-zero eigenvalues has exactly 1 element. So at least one value has a non-zero eigenvalue. Other values may be 0. Fine. So if I consider this as again 0. So this is my matrix A which satisfies this property. What is the rank of this matrix? Rank is my 1. So okay, but he said less than or greater than. Fine. What will happen if I consider is my say 3 cross 3, because in this case it less than 1 also satisfies greater than. So let's say R is 1, 3 cross 3 it has 1 here, so rest are say my 0. Fine. So this is the set of all its non-zero eigenvalues has exactly R elements. I consider R is my 1. Now what is the rank of this? Can you say rank is less than equal to 1, or rank is definitely say greater than equal to 1? If I say this is alpha, or I can simply take say it's a 2 3 4 0 0 0. What is the rank of this matrix? It is my 2, which is greater than of the R. So it's a greater than or equal to. If I consider this as a 0, then rank will be 1. If I consider this as a 10, then it will be greater than or equal to R. So this option is the correct. This option is cancelled. A square has the R distinct non-zero eigenvalue. That's the wrong option. If I consider this value are there 1 and minus 1, if I consider R is my 2, these are the distinct eigenvalues, but A square is a 1 1, so that's a distinct. It's not a distinct, these are the same. It's a cancel out. If R is my 0, then the rank will be, if I consider N is my 3, R is 0, it means set of all the its non-zero eigenvalues has exactly 0 elements, and R is 3, so rank will be less than equal to 2. What is the meaning of that? If I consider R is 0, so none of them is there, so what is the rank of this? Rank is always be less than equal to, that's not always 2. If I consider this value as a 2 here, fine, because in this case it's simply said, so it definitely this equation will not satisfy for this example. So because there is only one correct option, so C is the only right answer, rest already cancelled. Okay, what is that? P square is equal to P. Do you remember what is that? This is idempotent matrix. Fine. Now what is the tips for you? Once this idempotent matrix, then the rank of the P is always be equal to the trace of the P. Also the rank of the I minus P is same as that of the trace of the I minus P. Fine. These are simple tips for you. What are the eigenvalues? What are the eigenvalues of this? Eigenvalues are 0 and 1. Fine. But not always. Remember, not always. Why? Because if I simply take P is equal to I, what is that? Is satisfied? What is the eigenvalue of the, this is a 1 1, so that's why this is the, it's not for the not always. Fine. So either 0 or 1, either 0 or 1. Now look at the option. Trace of the P is irrational number. So what is that? It's either the 0 or 1, but the trace will be either 0 or 1. Both are 0, both are 1, or 1 0 1 are. So in this case trace will be the rational number, so first option cancel. This is by property. This is the tips for you. This is a satisfied. Trace is an integer, that's true. Trace is an imaginary complex number, that's a wrong option. This is the, so if somebody asks you the trace of I minus P, that's also the correct answer. So B and C are my correct options. Okay, A raised to power 20. Again, if I found the eigenvalue of the A as this, eigenvalue of this as, remember, whenever there is a matrix given to you, then always try to find the eigenvalue. So either you can write as a determinant equation, but you can see the column sum is 5, column sum is minus 3, not same. Row sum is 1, row sum is 1. So you can see row sum is my same is 1. So one eigenvalue is my 1. So since it's a 2 cross 2, the trace will be my 2, so other eigenvalues also be a 1. So if it is here, so you can see what is the eigenvalue of the A20, it is also be a 1 comma 1. So we can check firstly the row sum, not 1, row sum 1 1, you can see it's a 1 1, so one eigenvalue will be 1, is this right answer. And moreover, other eigenvalue trace will be my 2, so one eigenvalue is 1, trace is here. This is my plus 1, this is my plus 1, that's here. So but trace f is my 2, that's also there. This is my 1, this is not 1, this is 1, this is not 1, this is not 1, this is not 1. So I think both are the correct options of this problem. You can see 2 options are my correct one. Trace is 1, column is 1, so 1 and 1. Okay, look at this system. Ax is equal to b. There exists AB linearly independent, AB no solution are here. Okay, fine, this is a 3 cross 5. So first property, rank is always be less than of the number of the rows, number of the columns. It will be less than equal to 3. The last one is rank is 2, but you can see there is at least one minor whose determinant will be non-zero. So rank of this matrix is always be my 3. So third option is cancel out. So once the rank is my 3, what is the meaning of that? This is my dimension of the row space as well as dimension of the column space. So if you look about this third option, for all the values of the A and B, the row space has a 3-dimensional subspace. That's the correct statement. If it's a 3-dimensional, then it means its a rank is my 3. There exists a value of the A and B such that Ax is equal to 0, x is equal to 0 is the solution. So when it will have a solution, when rank of A, rank of this is my number of the column vector is my 5, but this is my 3 is not equal to 5, it has no solution, but he said it's a solution, it's a cancel out. For there exists a value of the A and B for which columns of the A are Li, but can you there exists a value of the A and B for which column of the A and there does not exist A and B. How? Because the rank is my 3, so it means this value must be a 0. So there is no pair of the A and B for which columns are Li. So this means these are cancel out. Right option is third option. Okay, A is my m cross n, rank of the A is my n. So I already told you rank, if it is a m cross n, it must be less than of the m cross n. It is given that it has a rank n. What is the meaning of that? N has less than value. Then which of the following is the correct statement? So Ax is equal to b. It has a solution when rank of this is same here, has a solution, either the unique solution or infinite solution. In each of the case, it must be equal to the number of the column vector. Column is my n. For this case is here, and for this case is not equal to n. Rank is my n. What is the rank of the A cross B? So you can see these are the values. What is that? This is my m cross n. So if this has a rank m, this has a rank n, and n must be less than of this, so it means the last value must be 0. And for any b, if I simply take the b as my here, what is the rank of this? N. Rank of the A condition B is my m, because of these non-zero elements, both are not same, so it does not have a solution. Ax is equal to 0 does not have a solution. Ax is equal to 0 when it have a solution, when the rank of the A is my number of the column vector. So what is the column vector? N, but it's the same, so it means it has a solution, it has a unique solution, so this option is cancelled out. Ax is equal to b has a unique solution, then it is a solution. So Ax is, when it will be the solution, when rank of the A is here, it must be n. Fine, then if it is there, then it is a unique solution. That's the correct statement. Y transpose A is 0 for some. That's not true. This is only true for the symmetric matrix, because if you have Ax is 0, if you take that transpose, this has a solution only when A transpose must be of the A. So but A is any of the matrix, need not be the symmetric matrix. So the right answer is C is the right answer. Okay, you have to find the dimension of this Ax is equal to 0. What is the meaning of that? They are talking about the dimension of the nullity. How you find the dimension of the nullity? Dimension of the nullity is my n minus rank of the A by rank nullity theorem. What is the dimension of this? 20. What is the n? Number of the column vectors. Number of the column is my 50. What is the rank? Row space has dimension. Dimension of the row space 13. What is the meaning of that? Rank of the is also 13. So right answer is 37. So D is my correct option. Okay, which of the following is here? So that's simply I can write the matrix 1 2 1 2 1 minus 1 3 3 0 0 1 1, and this has a B. Fine. When it has a solution, when rank of A condition B are same, then it has a solution. So how you can make them? I can simply take R3 minus R1. So this number will be 0. This number will be my minus 3. This number will be minus 3, 1, 1. This value will be cancelled out. If I take R2 minus of 2R1, so this value will be 0. This value will be my minus of 3. This value will be my minus of 6. Sorry, 6 minus 3 is a plus of minus of 3. It is plus 1. It is my 5 minus of 10 is my minus. 5 minus 10, 5 minus 12 is my minus 7. Now you can see, if I take, now these two rows are same. So if I subtract them again, it will be 0, 0, 0, 0. It is 8. So this has the rank 2. The complete has the rank 3, which is not same as the no solution is the right answer. Fine. Next one is A is my n cross m. B is my n cross 1. Ax is equal to B has a unique solution. That's very simple. When it gives you a unique solution, when the rank of A, rank of B is the number of the column vector. Column is here. So what is the meaning of that? Now think about here. This is my B is my n cross 1. So this is my n cross m matrix. Fine. This is 1 1 something up to here. When it will be m? When it will be m? When the last row of this must be the 0. Otherwise the rank will be n, and we need a unique solution. It will be the m. So what is the meaning of that? The rank of this matrix will be less than of the n, or you can say we need a m to be here. So we all know this must be rank of the n comma m. So when it will be the m, it will be m only when your m will be less than or equal to the n. So that's the only condition given to you as of this case. That's a simple, there is no need to write here. You can simply think about here. If A is my n cross m, by using this property, we can easily see when it will be the m, when m has a at least lesser value than of the m. So m is less than equal to m is the right answer. Okay, which of the following is the system is consistent? What is the meaning of the consistent is? Unique solution or infinite many solution. That means rank of A, rank of the A condition B is number of the column vector is 2 or less than of the 2, but it must be same. So how you can solve such kind of the case? There is no need to write the rank. Firstly, you can think about that. Firstly, I can take k is equal to 2. The solution will be 2x plus 2y is equal to 0. Second value is 2x plus 2y is equal to 2. Is it possible? The first give you a 0, second give you a 2. That give you no solution. So, but we need a consistent. So this option is cancelled out. Look at the minus of 2. The first one is 2x minus 2y is my 4. Second is minus of 2x plus of 2y is my minus of 2. Clearly say that again it will give you no solution. So this option is also cancelled out. Look at the first option. When k is equal to 1, so it's a 2x plus y is equal to 1. It's a x plus 2y is equal to 1. It's a y plus z is equal to 0. Now from these two you will get a value of the x. There is no need to find the value of the x because they are not talking about the what's the value of x. You will get the value of the x, you will get the value of y, because you can see that determinant of this is non-zero. So you will get the unique value of the x and y. Once you know the unique value of the y, you can substitute here, you will get the unique value of the x. So it means it has a solution, that's a consistent. So this is the right answer. Now look at this third option, minus 1. If you substitute here, 2x minus y is equal to 3, minus x plus 2y is equal to minus 1, y minus z is equal to minus of 2. Again you can see that determinant will be non-zero, so you will get the value of y, you will get the value of the x as a unique. Once you get a unique here, you can substitute here, you will get the unique of the z also. So it means it's a solvable. So the right answer is A and C, both are the correct answers. Okay, which of the following has for all the values? So when the rank of A, rank of B is number of the column is 3. Fine. So we can check the determinant of A. What is that? 2 times 2 minus 15 minus 0 plus 5, 5 plus of 2. So it is a 13, 26, 7, 35, which is a non-zero. So what is the rank of the A? Once the determinant is a non-zero, it means they are Li, so the rank will be my 3. It's satisfied, so it means it has a unique solution. So unique solution for all the pairs of this. Why? Because if this is my matrix and this is my y1, y2, y3, if this has the rank 3, if this has a rank 3, whatever the value of the y3, the total will also the rank 3. So it means irrespective of the value of the y1, y2, y3, it has all the solutions. So this is the right answer. Okay, so you have to find the dimension of the V. What is the V? V is the vector space of all those n cross n matrix such that Ax is equal to 0. Okay, so this is my nullity. Fine. So you can find firstly the dimension of the nullity. So what is that? N minus rank of this matrix. So n is number of the column. Here n. What is the rank of this matrix A? A is n cross 1, whose rank is so n minus r. But this is the dimension nullity of this. How you can find the dimension of V? V is the vector space. That is nothing but number of the column vectors multiplied by dimension of this. So how many column vector of the V? What is the column vector of the V is n. So n into n minus r. So that will be n square minus nr is the right answer of this problem. Okay, T is the mapping from Rn to Rn. This statement implies the bijective. What is the meaning of the bijective is 1 1 on 2. What is the meaning of the 1 1? 1 1 means determinant of the matrix is a non-zero. Once determinant of the matrix is a non-zero, rank of the matrix will be n. Fine. So nullity will be my 0 by using the rank nullity theorem. So check that. Nullity will be n cancel. Both are same, cancel. N plus 0 is 0. N plus 0 is n satisfied. Both are satisfied. Now rank plus nullity is my here. This is for all transformation. But whenever this is onto, what is the meaning of that? Rank. What is the meaning of the onto? Rank minus nullity will be here. Or you can see for the nullity of this will be 0. So once nullity will be 0 here, so if you simply add them, because this is a general statement, if it is there, so you will get as cancel out is the right answer of this. This is for the journal one, but once it is bijective, then it will be the minus of the n. Okay, look at the next example. V is the vector space of this. So I think that's a very simple. You can simply solve this one. So m will be my 1, 1. So solution will be here. plus C2 x e raised to power x. So what is that? This is my f. Now you can take their derivative, f1 cx c2 x plus 1 of ex. So what is my transformation? f1 f dash at the point 0. So this is my c1. So c1 plus it will be 0, 0, 1 is here. What is my f of 0? This is 1, this is 0, only c1. So since it's a transformation, we can write the vector as a column B. So c1, coefficient of the c1 is c2. So 1, 1, 1, 0. This is my matrix T. Fine. Now you can clearly see that determinant is a non-zero, so it's a 1, 1. Then how you can check whether it's a onto or not? So corresponding to the each pair A comma B, if I take this pair as C1 plus C2 and C1. So C1 plus C2 and C1. So clearly see that C1 is B, C2 will be A minus B. So I can substitute here, this is B e raised to power x, A minus B e raised to power x. So for each pair of the A comma B, there exists a function, so it is onto as well. So that is a bijective. Rest all are cancelled. Okay, A is a 4 cross 4. Null space is given to you. You have to find the dimension of the null space. How you can find the dimension? The first method is you can write in this form x, y, z, w, x, y, w here and write in the row reduce, but there is no need. Look at that. Check about the nullity. Dimension of the nullity means free variable, number of the free variables. So in the first line here and in this line x plus of this x and y are my dependent variable, w and z are my free variables. So it means how many number of the free variables? 2. So the dimension is my 2, and the dimension of the null space is, that is a nullity, is my 2. But he said dimension of the column, that means they are talking about the rank. What is the rank? Column vector 4 minus 2 is my 2. So dimension of the column space is my 2 is the right answer. So rank is 1, cancel, this cancel. Is it the basis? When it will be the basis? If it's satisfied here, check is it satisfied? No. So the right answer is only B, because this is the basis of them, it must satisfy this condition. Okay, R3 is the inner product space. W is spanned by 1, 0, minus 1. Which of the following is the subspace of the orthogonal? So remember, we all know the orthogonal property is dimension of this is my n. What is the n is? 3. So dimension of W is my 1. So it must has a dimension 2, but it has a dimension 3. Cancel out. So all are correct. Now which one of them? Orthogonal. What is the meaning of the orthogonal is? Inner product will be 0. So check about the dot product. 1 plus 0 minus 1. 0 satisfied. 0, 1, sorry, 0, 0, 0 satisfied is the right answer. 1, 2, 1. If you multiply them, is a 1, 0, minus 1 satisfied. 0, 1, 0. 0, 1, 1. 0, 0, minus 1, which is non-zero. So cancel out. 2, 1, 2. If I take the orthogonal pair of this, 2, 0, minus 2 satisfied. 4, 2, 4. 4, 2, 4. 4, 0, minus 4 is also satisfied. So this is also the right answers. So right answers are first and the third are the correct options of this example. Okay, look at this one. A is my 1, 0, 0, minus 1. F is my here. Fine. I can also written this as, or because this is a symmetric matrix. Okay, so I can also written this in terms of the inner product. Fine. There exists the eigenvector of this. So firstly we can check about the eigenvector. Eigenvalues are 1 and minus 1. So corresponding to the 1, this is the eigenvector. Corresponding to the 0, this is the eigenvector. Fine. These are the eigenvector given to you. So we will check about A is perpendicular. So this must be the 0. Fine. Or you can say W transpose, that is a V transpose of AV must be 0. So if I take about here 1 0, A is my 1 0 0 minus 1, and this is 1 comma 0. So check whether this will be the 0 or not. So it clearly says that it will be 1. First value will be, it's a 2 cross 2, it's a 2 cross 1, so it will be 2 cross, it's a transpose, sorry. So it's a 0, it's a 1, it's a 0. So what is that? It's a 1 0, it's a 1 0. So it's a 1 which is non-zero, but it's a perpendicular. First option cancel out. F of V is 0 is a non-zero subspace. What is the meaning of that? This is my here. So what is the meaning of that is V transpose AV is my 0. So if I consider V is my xy, so this is my xy, A is my 1 minus 1, and this is my xy. So what is that? Again, because of the symmetric, so it's a quadratic form. So we can write directly, this is x square, this is my minus y square. So what is the meaning of that? X is my plus minus y. So subspace will be my x plus minus x. Fine. Now you can see 1 comma minus 1 satisfied, 1 comma 1 satisfied. But if you add them, because subspace properties, u plus v also belongs to them. So 2 comma 0, which is not of the form of here. So this option is also cancelled. Third option is, again, third option is similar to the first one. If this satisfied, it means I have the pair of x comma plus minus x. If WW is there, then I can say it's a plus minus a. Fine. Now what is the meaning of that? If I say this means, if I simply take 1 or 1, it's satisfied, 2 and 2 satisfied, but one of them is a scalar multiple of the other. Is it true? This is true. But if I second pair I consider as a 2 and minus 2, so clearly says this can never be written as the scalar multiple of the here. So it is not of this. So the right answer is fourth is the correct answer. Okay, look at this one. This inner product space. W is my span of 1 minus t square, 1 plus t square. V is the vector space of degree 2, at most 2. So it has the dimension of 3. Fine. Of this, W is the orthogonal complement. So which of the following is there? H is even and so. So it's a polynomial. Firstly, I can think about any of the polynomials. This is my even polynomial. So check about whether this property holds. I can take F and G belongs to this. So if I take x square, 1 minus x square, check whether this will be the orthogonal property. It must be the 0. So it's a x cube by 3, x5 by 5. So clearly says it will not be 0. So it means even is not satisfied. If I simply take odd function, so h is my say x. So again this property x of 1 minus x square, it will be x square by 2, and it's x4 by 4. Clearly says again it will not be 0. So this also cancel. H of 0 is my 0. H of 0, again if we think about here, this is not satisfied. 0 is my even function, so this is also not satisfied. So the right answer is only C, because we discard the rest of them. Okay, look at this is the inner product. Which of the following is the inner product? We all know what is the property of the inner product is. It is always greater than 0. This is equal to 0 if and only if x is equal to y. Okay, which of them? So look at the option firstly. First we will see a is equal to 0. What will happen of my p? 0, 0, 0. So this is my b square x2 y2. So my property will be inner product must be greater than equal to 0 for all the pairs of the R2. Is it possible? No, because if I simply take the pair as minus 3 plus 4, which belongs to the R2, x2 is my minus 3 here. So you can see the product will not be 0. So A cancel. If A is my greater than 0, B is greater than 0. Okay. You can think about any of the number. So if I think about any of the number, okay, I can simply take x is equal to y, means x1 is equal to x2, y1 is equal to y2. So what is the result is, this will be my a square x1 y1, this is my x1 y1, this is my x1 y1. So it's a 2 times ab x1 y1. This is my x1, this is my y1. So it is my b square, sorry, x2 will be my x1, y2 will be my y1. So it's x1 y1. So it is my b square x1 y1. So it is a plus b whole square x1 y1. So if I say, can it be 0 always? No, it can never be 0 for different pair. If I simply pair x comma y is my here, and a is my greater than 0, say 10, b is my say 11, so clearly say that it will not be 0. It will not be 0. So it means this option cancel out. Similarly, if you look about that, ab is greater than 0, so it will be 0 if I take a is my 4, b is my say minus 4. So product of them, this will be 0, satisfied. It will be 0 when x and y, it will be happen only when a is equal to minus b, but the product is non-zero. It's not be less than, not a greater than 0. So the right answer is only D, rest options are cancelled. Okay, look at this another one. Here A is my symmetric matrix, so I simply take 2 cross 2, any of the 2 cross 2 symmetric matrix. So here is my, then there exists x. Remember, they are not talking about that for all x. So this, if you look about this property, what is that? It look like say it's a negative definite quadratic form, but as I told you in the first 2 examples, if this is for all x, but it is not for all x, it means this is not a quadratic form. If you think about that, this is a quadratic form, then definitely this is a negative definite, and you will get the wrong answers. So look at that. If I consider this as symmetric, if I consider this value, there exists a x such that this value will be satisfied. So what is that? If I say this pair will be here, no, this will not be satisfied. If I take this as a negative, again this is symmetric. How you can take the quadratic? This is my x square minus y square. It can be less than 0. So what is the determinant of this? Is it a less than 0? In this particular example, yes, it is true. Okay, but because I consider this one particular example, can you think about any of the other example whose determinant will be, if I simply say minus 1 minus 1? Fine. So now this is the quadratic form. How you multiply the quadratic form? This is the a1 1. So if I consider the pair as x comma y, this is a 1 1. So this is the x square, like minus 1 xx. This is a2 2 minus 1 y y y. So what is that? This is minus x square minus y square, which is always less than 0. So this property is satisfied for this. So what is the determinant of this? Determinant of this is my plus 1, which is not less than 0. Fine. What is the minus of a? If I consider this as a minus of this, so 1 0 0 1. Is it positive definite? How you can check whether it's a positive definite? What is the property of the positive definite? All the eigenvalues are greater than equal to 0. Fine. So how you can check that? If I simply take a matrix like of the previous value I have taken here, what is that? This case. So if I think about, can this be less than 0? There exists definitely. If I take x is 1, y is equal to 2. Fine. So what is the eigenvalue of this? Eigenvalues are 1 and minus 1, which is not greater than 0. So it means if this is my a, what is the minus of a? Is my minus 1 0 1 0. What is the eigenvalue? Minus 1 and 1, which is not greater than 0. So if it is not greater than 0, it is not a positive definite. There exists y, and this is for all y. Fine. So what is the A inverse? How you can find the A inverse? That's again a very simple. Same example I have considered. Look at that. If I take the same example like of this 1 0 minus 1 0, what is the A inverse of this? Minus 1 0 1 0. Fine. This is my A inverse. Oh, sorry, divided by minus 1 also. So A inverse is same. Now if I consider the any of the vector x comma y, then x transpose of x of this, it is my x square minus y square. Fine. Now there exists y, means can you think about the pair of the x comma y such that this will be less than 0? Yes, you can easily take 1 comma 2. This is less than 0. That's the correct statement. But he said for all. That is not true. If you take the vector as a 2 comma 1, then it will be 4 minus 1 greater than 0. So this option is cancelled out because of this for all is my third is the right answer. Okay, again this is a quadratic form. What is the meaning of the quadratic form? You can write the matrix, and if you find that all the eigenvalues are greater than 0. How you write the quadratic matrix? Coefficient of the x square, like of this. In journal, if it is a square plus bxy plus c of y square, then it is a and it is c. Coefficient of the y square, c, and half of b, half of b. Remember, this is always be the symmetric. So for the first case, 0, 0, half and half. So what is that? Or you can see, you can find the principal minors. If you find the principal minor, if it is greater than 0, means the first principal minor, what is that? First value must be greater than 0 and determinant of them will be greater than 0, strictly greater than 0. But the first value will be 0, so first option is cancelled out. Look at that, how you can write the matrix. 1 minus half, 1. The first value is 1 greater than 0. Second is 1 minus 1 by 4, which is greater than 0 is the right answer. Look at the third pair. 1, 1, 1, 1. First value is 1 greater than 0. Second is 0, which is not greater than 0, is a cancel out. Look at the fourth option. 1, half, half, 0. First value greater than 0, satisfied. Next value is minus 1 by 4, which is less than 0, not a positive definite. This is a negative definite. Once they are opposite sign, that's a negative definite. Or otherwise you can find the eigenvalues. If you find that all are my greater than 0, then it's a positive definite. So the right answer is my B. So again, this is the same case. You have to find a non-zero trivial. So now it's a 3. So it's a ax square plus bxy plus cyz plus dzx plus y square plus z square fe. So a, e, f, rest pair are b by 2, and so on. So look at the first pair, x, y, z. X, y, half, half, rest values are 0. Fine. So now, can you find first pair is a 0? Fine. Second pair is the determinant of this is a minus 1 by 4. You have to find the pair A, B, C such that this value will be whole. So you can see, because we need a 0, so one value of the 0 satisfied here. Look at this value, 1, 3, minus 2. Rest values are 0. So clearly sees the first pair is 1, which is greater than 0. Second is 3 minus 0, 3 greater than 0. Third is my minus 6 less than 0. But none of the values is my 0, so this option is cancelled out. Look at the another one, 1, 1, 1, minus half, 0, 0, 0, 0. First value is 1 greater than 0. Second value is 1 minus 1 by 4, again greater than 0. Third value is my itself 1, which is greater than 0. None of the value is 0, so this option is cancelled out. Look at the last option, 1, 1, 0, half, 0, 0, 0, 0. Clearly says that 1 is greater than 0, second pair is 1 minus greater than 0, third pair is minus 1 by 4 is less than 0, but it is not 0, so it's a cancel out. Right answer is only A is the correct answer. Okay, which of the following is my here? This is the last question, I think. Yes, this is the last question. What is given to you? T4 is my 0. What is the meaning of that? T4 is 0, it means this is the nilpotent matrix. All the eigenvalues are my 0. It is not a diagonal. Ki is my dimension of the kernel of Ti. That means nullity of Ti. Which of the following is not the possible values for the pair of x, k1, k2, k3 and so on? Okay. What is the k1? Dimension of the nullity of T1. K2, dimension of the nullity of T2. This is a nullity. And so on. K3, K4. Which of the following is not? Look at that. If you think about the K3 and K4 are always same, there is no need to check about that. we will check whether k, firstly we will check about k1 here. So it means k1 is the dimension of nullity of the t raised to power 1. We will check whether, it means I have to check what is that, size is 4 minus dimension of the rank of t raised to power 1. So if it is a 3, it means you have to think a matrix such that whose dimension will be, whose rank will be 1, then only it will be 3, and t4 will be my 0. So can you think about that? That's very simple. You can take 4 rows and last value are here. Clearly see the rank of this matrix is 1. If I found the t square, 0, t cube 0, t4 0. So rank is 1, 4 minus 1 3, so k1 will be 3. That's satisfied. But we need a node, so this option is cancelled. Fine. Now we will check whether the k2, how you can check about, is a 2. If I check about the 2, if this option cancel out, then it is the right answer. Can you think about the matrix whose 2, it means the dimension will be 2. So we can think about here 2 row column I can consider as a 0 and 1 here, and in this case I can consider somewhere as this. Clearly says that the rank of this matrix is my 2, nullity will be my 4 minus 2 is my 2. Fine. What is a t square? So these values are my 0 0. So if I multiply this first row by second column, this value will be 0, second row also 0, fourth row is also 0. Now we need to check only these values are there. So what is the answer of this? If you multiply t square into t, what will be the answer of this? It is again my 0. So again t square will be 0, t cube will be 0 and so on. It means nullity is my 2 is satisfied. So it means this option will not be there. Only rest option is my B is the correct answer of this problem. Fine. So that's a very simple, because I already told you, because these columns is my 0, so this value is already 0, this is already 0, this row is 0, this row is 0. So it means you need to only compute these 4 values, and clearly say that when you multiply this by, it's a 0 and 0. So t square 0, t cube 0, all are here, and you are able to obtain the rank as 2 or nullity as a 2. So these 4 options cancel. Right answer is only B is the correct answer. So I hope you can easily learn the various shortcut tricks in this PY questions. We will see the next lecture on the PY questions December 11 to 23, again with the help of the various shortcut tricks. Till then, you can simply like, share and comment on my videos. Best of luck students. Happy learning.